Hello and welcome to our lecture on Management Information Systems. Today we'll be looking at the foundation of business intelligence, and that is database and information management. All right, so by the end of this lecture, we want you to be able to answer these questions. What are the problems of managing data resources in the traditional file environment? Yeah, then the major capabilities of database management systems, and why is a relational database management system so powerful? Yeah, then the principal tools and technologies for accessing information from databases to improve business performance and decision making. Yeah, and then why are data governance and data quality assurance essential for managing a firm's digital resources? And then finally, how will MIS help your career? All right, so let's start with some file organization concepts. Yeah, so database technically is a group of what related files. Yeah, so this, you could think of it as a big container, yeah, where all data is organized and stored. Yeah, then a file as a group of records of the same type. Yeah, then we have a record as related fields, and then a field as a group of characters, like a word, number, or even a symbol. Yeah, and also more importantly is an entity. So usually when it comes to developing our databases or even developing our information systems, because at the back end of every information system, like our UPSA learning management system, is a database. Yeah, and this database, you need to identify the entities, yeah, before you can build the database. And usually the entities, yeah, are the people, places, or things you want to store information or you want to collect information about. Yeah, so if we take the UPSA learning management system, for instance, yeah, the entities will be things or people or places we are interested in storing information about. So yeah, obviously student will be an entity. Then we also have our courses being an entity. Yeah, perhaps yeah, your exam will be an entity. Your hostels will be an entity. Yeah, departments can be an entity, and so on. Yeah. Then finally we have attributes. So these are just the features or the qualities of these entities. So how we qualify our entities is what we call the attributes. All right, so this is the data hierarchy, and that is how we store or organize data in our computers. Yeah. So from the very bottom is the bits, which could be a 0 or a 1. Yeah, and then we can have a stream of these bits, yeah, given us a byte, and the byte is actually the standard unit or the basic unit of measurements, yeah, for data or storage in our computers. Yeah, but the smallest unit is the bits. Yeah, but when it comes to measuring our storage, we don't use the bit, we use the bytes. Yeah, so that's why you talk about yeah, kilobytes, megabytes, and then yeah, and so on, and not megabits or kilobits. Yeah. Okay. So yeah, moving on. Yeah, going up on the data hierarchy. Yeah, we have the fields. Yeah, so you have yeah, the field making up of bytes that represents specific data items. Yeah, so this could be your first name, yeah, your date of birth, your course code, and then so on. Yeah. Then when we yeah, group these fields together, we get a record. So we have yeah, multiple fields really coming together to give us the record. And then as you can see in the figure, that is a student record. So you have the student ID, yeah, course code, date of birth. So these are actually fields we are grouping together. Yeah, and then it belongs to one student. Yeah, so that gives us a record of an entity. So that is an instance of an entity. So when we talk about records, we are looking at what instance of what entity, the fields that are related to instances of entities. Yeah. Then also we have what a file, yeah, which contains related records, like a set of what students, yeah, or course information. Yeah. So that gives us what yeah, the file. Yeah, so when you put this records together, it gives us a file essentially. And then finally we have what our database as the collection of what these related files. Yeah, so for instance, you could have what your course file, your financial file, and then your personal file. So these are all what separate files, but when you put them together, you have what your database. Okay, so let's also examine the problems of the traditional file environment. So when computers started in what 1959 with the mainframe computers, as we have looked at in what IT infrastructure lesson, yeah, we realized that yeah, the computers we have today, yeah, were not there some time ago, and then yeah, computers never started like this. We started with the mainframes, yeah, then it evolved to what the mini computers, then we came to what the personal computers, and then we went to what, yeah, client server computing, enterprise computing, cloud computing. Yeah. So throughout this period, how data was what stored or organized, yeah, has evolved as well. Yeah. So with the early file environments, you realize that yeah, various departments maintain what separate files. Yeah, because it was early days. Yeah, businesses were embracing what computing. Yeah, and they were all going for programs, and then what yeah, applications for their various activities or functions within their units. Yeah, so you realize that there was not so much what synchronicity, yeah, in how these programs were what developed and how data was what stored. So this created what a number of issues, including what data redundancy. Yeah. So you realize that the fact that they were all storing similar information, or at times the same information, yeah, in multiple locations, because the HR will store, accounting and finance will store similar or the same information. Yeah, manufacturing will store similar or the same information. Yeah, so that was just duplication. And yeah, at that time, yeah, storage was expensive. Yeah, so that's created what we call redundancy, because the data was redundant. It was stored in multiple locations. Yeah. And then yeah, obviously redundancy will lead to what we call data inconsistency. Yeah, so that led to what we call data inconsistency, because yeah, it was just so difficult to get everybody, yeah, to update the same data at the same time. So since they were storing what the same or similar data, it was just impossible to get all of them to be updating the same data, yeah, at the same time. Yeah, so that was not just practical. Yeah, so there were times you could enter a department, just ask them, yeah, how many employees do you have currently? They'll be giving you different figures. Or you go to the sales department and you're asking them, yeah, how much of a particular item have we sold today? Or in the last week, or last month, and so on, and they will be giving you different figures. Yeah, it's because they were just unable to update, yeah, their databases at the same time. Yeah. So with the inconsistencies, yeah, we also had what we call program data dependence. And like I said, because of the early days, they were all pursuing, yeah, computer programs or applications for their various functions. So you realize that there was not so much synchronicity. Yeah, so they realized that the programs that were developed for them, yeah, didn't have yeah, so much there was not so much coordination. And if there is not so much coordination, yeah, you could store the same data in different ways. And when it comes to sharing data or allowing these programs or databases to communicate, yeah, there will be obvious discrepancies. Yeah, so the program data dependence was really an issue, and that also even led partly to what we call the lack of flexibility. Yeah, because anytime you had to transfer data from one unit or one department to another, yeah, it requires some intensive programming efforts to be able to do that. Yeah, so yeah, that also created the lack of flexibility. Yeah, and then yeah, it was just demanding to be able to query the database in ways that were not predefined. Yeah, so with each of the databases, they were predefined ways of querying the data. So it means you must go with that way. But if you want to do some ad hoc interrogation of your database, then it becomes an issue. You may have to engage programmers to be able to do that. Yeah, then we also have the issue of poor security. So the fact that each department was keeping their data, yeah, it was difficult for management to have oversights, yeah, on who was accessing the data, yeah, how much, when, yeah. So all of these were challenges with the traditional file environments. Yeah, and then finally, we had lack of data sharing and availability. So the isolated files limited collaboration. Yeah, it made it difficult for department to access and then share crucial information. So sometimes, even if the information was available and you were unable to really use it, yeah, or it was available but in a form, yeah, that was not meaningful or useful to you. Yeah, so that was still an issue. So we still said there was that availability issue. Okay, yeah, so this is a figure trying to illustrate the traditional file processing environment. Yeah, so from this figure, yeah, we could see that different departments organizing their data in different ways. Yeah, so for instance, accounting, yeah, human resource, sales and marketing, yeah, and then manufacturing. Each of them maintain their own application programs and then data files. Yeah, so for instance, the accounting and finance, they use programs, yeah, programs with derivative file A, B, C, and D for storing their data. And then human resource, they also use programs with files A, B, D, and E. Yeah, whilst sales and marketing and manufacturing, they also relied on separate programs and files. Yeah, so because of this isolation, yeah, there's bound to be redundancy, yeah, inconsistency, as we have mentioned, because anytime there is redundancy, yeah, it means you have to get people to be able to update all the isolated data at the same time, which was not practical. Yeah. So moving on, let's also talk about database management system, which is actually the solution to the problems of the traditional file system. So a database essentially serves many applications by centralizing data and controlling redundant information, instead of allowing each department, to store their data in isolation, the database centralized all the data in one location. Say that if you were updating, you only need one person to update it at a time, and then that applies for everybody. So so the database needed a management system, really, and that is what the DBMS, or the database management system. And this system acted as an interface between the physical data, and then the application. So it's sort of decoupled the program, and then the data, or the applications and the data. So once that decoupling was done, so you realize that anytime there's the need to modify either of the components, whether it is your applications, you are updating or changing your application, it wouldn't affect your data or your physical data. And at times, if you were making changes to your physical data, or you were replacing the storage compartments, it wouldn't affect your application programs and so on. So this really allowed us to solve the problem of redundancy, so ensuring that the same data isn't needlessly copied in multiple places. Then it eliminated inconsistencies by keeping more accurate data, since the update happens in one central location, and then also uncoupling program data, so that if you make changes to how data is stored, the program logic doesn't necessarily need to change. And then it enable centralized management. So in terms of security, you realize that organizations now have proper oversight over who accesses their databases or their data, at what time, how much, and then when. So they are able to really have oversight of all these things, and then determines who gets what privileges to the data. So in short, the DBMS is a unified way to manage, store, secure data across an entire organization, and this resulted in a smoother data handling, and it improved decision-making capabilities within organizations. Okay, so we have another figure here on human resource database, with multiple views. So if we look at it, the cylinder in the diagram represents the physical view of the data, where actual organization and storage of data happens. So we could see items like employee ID, name, social security number, pay details, and benefits, and so on. So these are in the physical database. Then the orange rectangles we have there are two. They represent the logical view of the data. That actually present different view of the data to different users. So you realize that somebody from the let's say welfare will be interested in employee benefits, and they will have a different view that will contain the name, the social security number, and then the healthcare information. And then those also in accounting and finance, or with HR, or some payroll, the department, they will also handle, or they will also be able to access the names of the employees, their social security number, the gross pay, and then the net pay. So you realize that essentially this is the same database we have there in the cylinder, but we are getting different views because of what the management information system, which is the blue rectangle in the middle. So that is just the interface. Yeah, that really what create that abstraction between what the applications, and then the physical data, that we, or the data files, in our databases. We could also even look at what the example of the UPSA virtual. That is the learning management system we all use. You realize that the view of what the lecturer is different from what the view of the student. So when I open what UPSA virtual, you realize that I will have what features that will allow me to create courses, that will allow me to create quizzes, and then mark quizzes and or mark assignments and so on. And with the students, you are also only able to just see the course information, read what course materials, take quizzes, and then submit your assignment and so on. So that is what you are also able to do, and that is the only view you'll be seeing. And then again, when you look at what the HODs, they will have what view of all the courses within the department. But a lecturer, I don't have what view of all the courses we have in the department, except that I'm taking that course. Apart from the courses I'm teaching, I don't have access to any other course in the department. Then you realize that within the within the faculty, we also have several departments, and the deans will be able to see all the courses you run in all the departments within the faculty. But HODs may only be able to see what courses within their departments. So all of this is possible because of what the management information system. So it is actually what presenting to everybody what you really need to do your work. So that is the essence, or that is one of what the benefits of what using the management information system. So it creates this abstract view of the database for what all users of the database, because of what our different roles and functions that we play. Now let's go to what relational database management systems. So this is a database management system where we store data in tables. So any database that we store data in tables, we call it what a relational database, because these two-dimensional tables that are actually what having rows and columns, and then what we establish relationships between what these tables. Okay. So there are also some important terminologies you have to note here. Rows are records for different entities. Then the fields represents attribute for entities. Then we have what we call the key fields. So these are the fields that uniquely identify records. So in database, usually creating a unique identity for your records is always important. So you are always looking at certain fields that will allow you to uniquely identify records in your database. So without that unique identification, you will not be able to really add records to your database, because it will just not make any sense that your data cannot be or your records cannot be uniquely identified. So the key fields usually potential fields that we can use to uniquely identify our records. Then the particular key field that we select for unique identification of records is what we usually call the primary key. So the primary key is the key that allow you to uniquely identify your records. And then the foreign key could be a primary key, yeah, from another table that used to look up what related records across what yeah, tables, or simply, yeah, you could just see it as what yeah, a key field that is what common to two or more tables. Yeah, so anytime you want to what establish relation, yeah, you need to have what a common grounds. Yeah, so that common, yeah, grounds, or yeah, that common field is what we usually call the foreign key. Yeah, so it could be in two or more tables. At times it could be what the primary key. Yeah. Then let's look at this figure. Yeah, so you realize that yeah, it is what a relational database that organizes data into what two-dimensional tables. Yeah, the first table here is what the supplier table, listing what, yeah, supplier number, the primary key, supplier name, and then what location details and so on. Yeah, then we have what the second table being the parts table that uses, yeah, its own what primary key, which is the part number. Yeah, but it also what includes supplier number as a foreign key. Yeah, so you could see that the supplier number is in what both tables. So that is why I always what simply refer to it as what the field that is what common to two or more tables. Yeah. Then you realize that yeah, that creates what a link, yeah, between what the parts, yeah, and then what the supplier table. So you could just use the foreign key to what create that link between the supplier and then what the parts table. Yeah, yeah. So yeah, so essentially that is what a relational what database table. So you could see it's not so different from what your Excel what spreadsheet. Yeah, this is not so different from it. Then let's also look at some three basic operations of relational database management systems. Yeah, that really allow us to retrieve information from our database. Yeah, so one of the important ones is the select operation. So this will allow you to filter, yeah, based on a specific what criteria. Yeah, that allow you to what create a subset of what all records meeting what, yeah, this particular criteria or some conditions you have set. Yeah, then we also have what the join what yeah, operation that allow you to what combine data from multiple what relational tables. So yeah, for instance, we can make the supplier table and then what the part table to see, yeah, both information, yeah, from what the suppliers, yeah, and that of what the parts in a single view. Yeah, then we also have what the project that extracts yeah, only certain columns from what a table, yeah, creating a new table with just what attributes you need. Yeah, so that is the project. Okay, so let's see how these operations are applied. Yeah, so if you look at this figure, yeah, so it demonstrates what exactly what the three operations that we have talked about: select, join, and then what project. Yeah, so yeah, so we can what yeah, see that. Yeah, so with the project, that is what yeah, that is the table below. You could see that it limits what the column to just what the part number, and then what the part name, supplier what number, and then supplier name. Yeah, displaying only these attributes. So this may be what attributes you are interested in. Yeah, and then if you look at what the, yeah, the join operation, yeah, we also have it what implemented here. So actually, yeah, we could use what the supplier what number, yeah, in this what yeah, so we could use the supplier number, yeah, and then what okay, yeah, yeah, so Yeah, we could use the supplier number in the past table to fetch matching records. Yeah, yeah, in the supplier table. Yeah, so that will give us yeah, information from what both the parts and then the supplier table. So essentially, we are joining the two tables together. Okay, then let's also move on to look at the capabilities of what database management systems, focusing on three key areas. Data definition. Yeah, so that is how we set up what the structure of databases, defining the tables, the field, the primary keys that we've talked about earlier on. Yeah, and then the data types. Then the data dictionary, yeah, that is the dictionary that stores metadata. So the metadata, yeah, describe what each field, yeah, so it contains the name, yeah, the type, the size, the format, or any additional yeah, properties like ownership or security rights. Yeah, so that is what the data dictionary does. Yeah, so in a large organization, you could have the data dictionary tracking who accesses certain files, yeah, how often, yeah, and so on. Yeah, then let's also look at data manipulation, yeah, language. Yeah, so this language is used for querying or reporting, yeah, from our databases. And one of what the commonly used one is what we call the SQL language, that is the structured query language. Yeah, so the select, the join, and then the project that we were talking about, yeah, are actually operations we can perform using the SQL language. So you realize that many database management system softwares like Microsoft Access, yeah, and then yeah, MySQL, yeah, so they actually provide inbuilt, yeah, report generation capabilities that allow users to yeah, transform raw queries into polish or professional reports, yeah, without needing separate tools or at times advanced programming skills. Yeah, but my SQL require maybe some, yeah, intermediate database programming skills. Yeah, I think later on we'll be looking at a sample yeah, SQL code. Yeah. All right. So we also have another figure here that really demonstrates the data dictionary features in Microsoft Access. Yeah. So you realize that at the top of the pane, yeah, you can see the field name, the data type, the description for each field, yeah, in the supplier table, yeah, and then you can also notice yeah, the key icon beside the supplier name, yeah, so this shows that it is the primary key. So you can just see this yellow key, yeah, so that shows, yeah, so once it is selected, so that is the primary key, then you can see that, yeah, attached to the supplier number, there is the key there, so that just indicates is the primary key. Yeah, because we have to be able to uniquely identify our records. Then also coming towards the bottom of the pane, yeah, we have yeah, the field properties displayed there. Yeah, so yeah, so this is where we define the characteristics, like the field size. Yeah, so how long it is. Yeah, is it a long integer, or is it a short integer? Yeah, and then the size of the characters, and so on. Then we also have the format, yeah, whether it is text, it is number, it is currency, and so on. Then we also have the input max, that is used to control how data is entered. Yeah, then we also have the default value. Yeah, so an initial value you can set for new records. Yeah, say that when yeah, before you even enter the data, that's what default value applies, and you may have to modify that. So at times, you can use this one, for maybe, let me see, days of the week, or perhaps months, and even numbers. So let's say there is some bonus that you offer, and then there is a rate. So you could set it as the default. And at times there are some data values that you just don't change often, or that is the same for almost everybody. So those ones you could set the default value. Then we also have the validation rule, and the validation text. So this is just to ensure data accuracy. So you realize that sometimes in your databases, you are restricted in what you can enter, what record you can enter. So let's say your date of birth. Any properly designed database should not allow you to enter a date in the future. So for instance, if you say you were born in 2030, the database should reject that, and then tell you that that is inaccurate. So that well, everybody born today is definitely not born in the future, so that cannot just be true. So you could actually put some checks there that will allow or some validation rule that allow you to prevent inaccurate data from being entered. And also even with our student examination results entry systems, you realize that your IA is over 40%, and then your final exam is 60%. So usually we'll set it in a way that will prevent you from entering more than 40 for IA, and then entering more than 60 for the final exam. So that is very easy to do. And I even believe in Excel, you are able to put in these checks. Then you also have the required fields. That's usually once you check this field, it means it becomes mandatory. So sometimes you're entering a form, or you're filling a form, and then you realize that some fields are mandatory. So that is always important in a database. We have to be able to regulate and demand important information from our users, such that people cannot refuse to give certain important information. So for instance, you shouldn't refuse to give your ID, your identity, and your name, and so on. So there are some fields we cannot just do without, so we have to make them mandatory. Then we also have the index, which determines whether access should organize a section or a sorting on a particular field. So you can choose to index your fields, and so on. Okay, so that is just the access data dictionary features we've looked at one by one, and then let's make some progress. Okay, so this is the SQL query I was talking about. So when you look at this query, actually that is just the SQL language. It's very close to human language, and if you look at it carefully, there is some sense to it. So what it's just saying is that you should select part number from part table. So that is why it says select parts dot part number. It means part number from part table. Remember our table is one of our table is called parts. That is the uppercase. But that is the entity. So usually your entities become your tables. So when you are creating a database, you start by identifying the entities, the attributes, and the relationships. And then when you create that database, yeah, the entities will become your tables. And then the attributes of these entities become the fields in the tables, and the fields are the columns in the tables. Yeah. So then we also select part name, yeah, from part table. So we have part name, then supplier supplier number. So it means select supplier number from supplier table, and then supplier name supplier. So select supplier name from supplier table. So the table names are in uppercase, and then the fields are in lowercase, and then the keywords or the operations, the SQL operations, yeah, are also in uppercase. Yeah. Then you can see that they are saying from. So if you are selecting, you have to select from somewhere. So from part and supplier table. Yeah. So you see, select from part supplier. So the parts is a table, the supplier is a table. So you are selecting from these two tables. Then you are given a condition. So where parts dot supplier number equal to supplier dot part number. Yeah, so you are saying that the condition is that the supplier number in the part table should be equal to the supplier number in the supplier table, and they are given yeah, a further condition, and part number should be equal to 137. Yeah, so you are looking for this particular part number, that is 137. Yeah, or part number equal to 150. So what it's going to do is that it's first of all going to yeah, join the two tables using the condition, yeah, and then it will go to this particular part number, yeah, 137, and then yeah, check if there is part number 150. So yeah, in this case, it's going to return both of these. It's going to return both of them. Yeah, because we are saying it should return if it finds 137, or if it finds 150. Yeah, so yeah, it's going to return both of them, yeah, in that case. All right, so that is just the SQL yeah, code. All right, let's move on to look at what's yeah, another figure here on access query. Yeah, so the same query is being applied here. The one we just saw, yeah, up there in SQL. Yeah, the same is being applied here, but this time you have a wizard, yeah, or a graphic user interface that allow you to yeah, really create a query. So this time you don't need, yeah, any coding to be able to create your queries. Yeah, so you will see that yeah, so you'll see that yeah, if we look at yeah, the top section, yeah, so yeah, you see that the part and the supplier tables, with their respective fields are listed, yeah, there, yeah, at the very top. Yeah, then the line connecting yeah, the supplier number, yeah, in both tables, yeah, that represent the relationship between the tables, yeah, and that ensures that you are able to join your data from the two tables. Yeah, then when you go down, there is a query pane at the bottom section. Yeah, so in this part, that is where the query parameters are set. Yeah, so you could see that the fields, yeah, under fields we have part number, yeah, part name, supplier number, and supplier name. Yeah, so these are actually selected for you to retrieve them. Then yeah, when you go to the tables, yeah, it indicates the which table, yeah, in each, yeah, which table each field comes from. Yeah, then the show, yeah, box is checked, and that it really determines, yeah, which fields will be displayed in your query results. Yeah, and the criteria there is yeah, the condition, Yeah, so that is the condition. That is 137 or 150 limits. Yeah, so that is what our query. Yeah, the same query we have seen in what, yeah, SQL language. All right, so now let's go to what look at database design. Yeah, so there are always some key consideration you should make, yeah, which are just what essential for creating your, yeah, your database. Yeah, so usually we have what we call the conceptual design, yeah, versus what the physical design. So with the conceptual design, yeah, here you try to focus on how our data elements will be grouped. Yeah, you try to determine the relationships between them, and then yeah. So here it's all about just what answering questions. What data, yeah, do we need, and how will we organize it? Then you come to what the physical design. So with this one, yeah, it deals with how data will actually be stored, yeah, and then access on the physical hardware. Okay. Yeah, then we have what we call normalization. So this is usually a process that involves, yeah, streamlining data groupings to really reduce redundancy and avoid awkward minute-many relations. Yeah, so you will realize that at times if we break down the large and complex tables into smaller ones, then yeah, we are just normalizing, yeah, the database table to ensure what efficiency, yeah, and consistency at the end of the day. Yeah, then we have what we call referential integrity. So this, whenever we enforce referential integrity, yeah, in relational databases, it ensures that the relationship between the tables remain consistent. So for instance, you cannot have yeah, so usually we look at them in the yeah, context of a child and a parent. Yeah, so usually your tables, yeah, we have what we call a parent table, and then a subordinate or a child table. So yeah, one table is always what subordinate to the other. Yeah, or in other words, yeah, certain tables cannot exist without what other table. Let's look at a practical example here. So let's look at the UPSA learning management system. Yeah, so you realize that the course table, so that is a course entity. Yeah, without the course entity, you cannot have an exam entity. So the exam will definitely depend on the course, because there cannot be an exam, yeah, that is yeah, not on any course or not on any subject. Yeah, so exams must be about courses, yeah, about particular courses and so on. Yeah, so it means you cannot have an exam if there is no course. Yeah, so if somebody cannot have an exam score, yeah, if there is no course, so you can have the score in the vacuum. Or in other words, we could also still say that you cannot have an exam score without a student, because it is students that take exams. So it means that the exam table is also still subordinate to the student table, because without the students, you cannot have the exam score, or you cannot really have exams. Yeah, so that is what yeah, some hierarchy. Yeah, so anytime, yeah, we are deleting records or we are updating records, yeah, we have to ensure that this referential integrity is enforced, such that we don't have in our database exam scores when we don't actually have students. Or even, let's say, it's your yeah, sales and marketing database or something. Yeah, you cannot have the sale of products that doesn't exist in stock. Yeah, that doesn't exist in stock, so it will just be fictitious, and then yeah, it wouldn't make any sense, yeah, to actually have sales Yeah, for products that you don't have in stock. Yeah, so that wouldn't make sense at all. Or yeah, it will mean that there is something wrong. Yeah, or something is yeah, recorded wrongly, and so on. So that is just by the way. Yeah, and then we have entity relationships. So you also have to really identify how these yeah, entities relate. So sometimes, yeah, there may be many to many relations between your entities. Sometimes it's one-to-one, yeah, relation between your entities. Yeah, and then at times even we look at the participation, yeah, between these entities. Yeah, at times there is full participation, and at times there is partial participation. So for instance, let's say we are looking at the relationship between the student entity and then what's the exam entity. So you realize that yeah, many students can take an exam, and then many exams can be taken by yeah, one student. Yeah, so in that case we have yeah, that many to many relation between the exam and the students. Yeah, but there are other cases where you may not have yeah, that many to many relation, or you may not have yeah, full participation. Yeah, so for instance, let's look at yeah, the students. Do all students take exams? Yeah, so if all students take exam, then there is full participation in that relationship. Yeah, and then yeah, are all exams taken by students? And if all exams are taken by students, then there is that full participation. But sometimes yeah, not all exams, or sorry, not all students take exams. Yeah, so we can't say there's full participation, because every time yeah, there are always reasons why some students are unable to take some exams. So if you are creating a database, you should yeah, think about all these nuances. Yeah, say that your database is really flexible, and then it can yeah, be able to yeah, fit the situation you are design the database for. Yeah, so if you don't properly analyze these relationships, yeah, you realize that okay, yeah, you didn't cater for this scenario, but yeah, you are confronted with that scenario, and then you may have to go back and redesign your database. Okay, so now we have a figure here on normalization, yeah, of relationships. Yeah, so this is an example of an unnormalized relationship. So you can see that it contains all the data elements related to the order, yeah, that we can make. Yeah, so from the structure of the table, it includes fields like the order number, order date, part number, part name, yeah, unit price, quantity, yeah, and then supplier information such as supplier name, street, and so on. Yeah, so all these fields, yeah, are in a single table, which might seem yeah, simple, but it presents some serious challenges. Trust me. Yeah. So yeah, so some of the challenges yeah, you can face with this unnormalized yeah, data are repetitions. Yeah, so since an order can include multiple parts, and then each part, yeah, may come from different supplier. Yeah, details like supplier name, address, and then city will be repeated for each line item in the order. In the order you are making. Yeah, then you may also have inefficiencies. Yeah, because this is redundancy. So it increases the size of your database, and that can affect yeah, the speed at which you even retrieve records, yeah, from the database. Yeah, so yeah, for instance, if a supplier address changes, yeah, every occurrence of that address in the table must be updated. That is also yeah, a lot of work you have to do. That is when you are keeping multiple yeah, copies of what the same information. Yeah, then errors, yeah, can also what crop up. So always repeating information increases what I mean the risk of inconsistency. Yeah, in what I mean the reports that you are going to create at the end of the day. Then let's also look at what yeah how we can address this. So this can be addressed by what I mean yeah performing some normalizations here. So yeah, so to normalize your data, what you can do is what I mean you split yeah the unnormalized what table into what smaller yeah related tables, and this will reduce the redundancy, improve efficiency, and then what I mean just ensure your data integrity. So let's move on yeah, to the next figure, that is 6.10. Yeah, so that table we're seeing earlier on, that is the order table. It has been normalized. Yeah, so that is the same table that has been what? Yeah, broken down into what? I mean, various parts. Yeah, so now you can see the actual order. Yeah, it just has two fields, the order number and then the order date. Yeah, then we have come up with another table called line item, supplier, and then what parts. Yeah, but when you just bump all these things together, yeah, in one table, it just creates the issues we have talked about. I mean, inefficiencies. Yeah, yeah, the potential errors. Yeah, so it's a good thing to what I mean normalize your tables. When you normalize the table, then yeah, it is much more efficient. Okay, so let's move forward, and then this is also the entity relationship. So earlier on, I just what I mean yeah made some highlights on that. So you could see that yeah, in representing them, we use what some notations. So you could see that we have what some two cross yeah bars here, and then we have what something like what yeah a rectangle, yeah, sorry, a triangle there. We call it the crow foot, okay? Yeah, it's just like the feet of the crow. Yeah, so that is the crow foot notation. So you can see that we have one bar and then what the crow foot. Yeah, so the crow foot usually mean what yeah, many relations. And then the double bars we have here means one and only one. Yeah, so it means that yeah a supplier, one supplier can what provide many parts. Yeah, they can provide one or many parts. Yeah, so one or many parts can be what supplied by just yeah one supplier. Yeah, then one part yeah can contain what many line items. Yeah, and then many line items yeah can be what contained in one part. Yeah, then we can also have what yeah many line items in one order, and then one order can actually what contain what I mean many line items. Yeah, so or include many line items. So that is what just the relationships they've what established between the various what entities. So now this becomes our entities. So remember, yeah, each of the tables in your database are the entities that you have identified earlier. Okay. So now let's move towards non-relational databases, cloud databases, and then blockchain. Yeah. So all along we've been discussing what's yeah the EBMS. Yeah, that is for relational what I mean databases. Yeah, but yeah there are at times these relational databases are just what I mean unable to what yeah handle yeah the kind of data that I mean we are really interested in today. Yeah, so today because of what big data, yeah we've realized that data is now what the fuel that is powering what I mean businesses, economies, and so on. So it is yeah essentially the most important assets yeah for your organization. Yeah, so the better I mean yeah the more and better data you have, what the better it is for your organization. Yeah, so because of that, yeah we have realized that our present what I mean structured relational databases are just unable to handle what I mean. Yeah, this large volumes and then wide variety of data that we are interested in. So, for instance, we are not only interested in what I mean the figures, yeah, but we are also interested in what video information, yeah, yeah, text, I mean, messages that are sent on social media, yeah, thumbs up, yeah, that emojis, and yeah, all manner of information, yeah, even the behavior of what I mean users on these what platforms, on websites, and so on. So all of this, yeah, is information that we are now gathering, or is data that we gather, yeah, these days, and that just requires us to what, yeah, get new types of what I mean, yeah, databases, yeah, that's no longer what I mean, yeah, required what I mean, yeah, to be structured. So they could be what semi-structured or totally unstructured. Yeah, so with this kind of what I mean, yeah, databases, we can use what the normal what I mean SQL language. So now we are using what, yeah, different what yeah languages. I mean to really what I mean analyze these data and so on. So that is what yeah, the no relational what databases, or we call them what the no SQL what I mean databases. Yeah, and in short, the reasons are what I mean for flexibility. Yeah, the data set. I mean, you want to store across what I mean distributed machines. Yeah, so that it can allow us to do what I mean. Yeah, deeper analysis so that we can extract insights, yeah, that what inform our decision making. Yeah, then what yeah, because of the size or the scale of the data, yeah, we also want to be what I mean able to, yeah, store a whole lot of this data. Yeah, then handle what I mean large volumes of what I mean unstructured and then was structured data. So we want to be able to do all of these things. Yeah, so these are the reasons why we what, yeah, have to move away from what's the SQL databases to a new kind of databases we call the no SQL databases. Yeah. So, I mean, continuing with what I mean, yeah, our discussion on what I mean, modern database, I mean, solutions. Yeah, so let's also focus on what I mean, cloud databases and then distributed databases. Yeah, so these what I mean offer businesses what flexibility and scalability. Yeah, in today's data-driven world. So you realize that the cloud databases, yeah, are hosted and managed in the cloud. Yeah, essentially it means what I mean we access them over the internet. Yeah, so that is what the cloud really means. It doesn't mean they are hanging there in the cloud, but yeah, they are what I mean remote, in some remote locations, and we are actually really accessing them um over the internet. So we just call them what I mean, yeah, the cloud databases. Yeah, because the symbol for what the internet is usually what I mean the cloud. Yeah, so they just what I mean, yeah, find it convenient, yeah, to refer to it as what, yeah, cloud databases, yeah, or cloud computing in other words. Yeah, yeah. So I mean, yeah. So this what I mean really what allow you to what, yeah, really focus on what your core business what objectives instead of what investing so much in what your IT infrastructure. So instead of what you're trying to have everything within your premises, you then what depend on, yeah, computing resources or storage resources that are what, yeah, provided over the internet by some of the major players in the technology industry, like Google, Amazon, Facebook. So all of these are what, yeah, cloud what I mean database I mean providers. Yeah, then coming to what I mean, yeah, distributed what databases. Yeah, so they take what scalability to a new what I mean level altogether. So you realize that I mean these I mean systems, they store data across what multiple physical locations. Yeah, so often in what different geographical regions. Yeah, so they design it to what ensure that I mean it is fault tolerant, such that I mean Yeah, if one location goes offline, then other locations, operate seamlessly. Yeah, so this is just what improve performance. Yeah, especially in the era of cloud computing. Yeah, see yeah, it wouldn't just augur well. Yeah, if you've really paid for computing resources, yeah, over the internet, and then when you need them most, you are unable to access them. Yeah, because at times, we can have natural disasters. Yeah, so that's why they don't want to locate yeah, all their cloud databases in one location. Yeah, so they will spread it across yeah, different continents. Yeah, say that there is some sort of coordination among these yeah, distributed databases. Say that, yeah, if one goes down, the other yeah, automatically takes over, and then all your data you have has been backup. So there is that systematic coordination and backup of your operational data in distributed databases across different continents. Yeah, so you could have one in Singapore, one in yeah, California, and then yeah, in Beijing, and so on. So anytime there is a problem there somewhere, there is a tsunami, a snowstorm, or something, yeah, or even in our case, if there is some doom, so yeah, so let's say there is yeah, some cloud database here, and then the power happens to goes off, yeah, but yeah, you can rely on yeah, a distributed database, maybe in Nigeria or Kenya or somewhere. All right, so now let's also look at another important technology, yeah, which is blockchain. Yeah, so blockchain is really a revolutionary technology. That really goes beyond traditional databases. Yeah, so yeah, at the core of the blockchain is a distributed ledger system. Yeah, that operates. Yeah, it's a distributed ledger system that operates. Yeah, so that operates, a peer-to-peer distributed database. Yeah, so that is, at the core of a blockchain. Yeah, a distributed ledger system that operates in a peer-to-peer network. Yeah, and it has key, characteristic features. Yeah, that make it really, really unique. Yeah, so yeah, it maintains a growing list of records or blocks. Yeah, so all the blocks, yeah, are in chains. Yeah, or they are shared among all participants within the network. Yeah, so that makes it really difficult for somebody to tamper with it, because you can't tamper with yeah, all the records across all the distributed locations. You may not even be able, yeah, to know all the locations to be able to tamper with all of them. Yeah, so and once there is some inconsistency, they are going to yeah, compare the rest of them. The rest that will look the same be used as the authentic record. Yeah, so yeah, so that means that there is no just central controlling, because it is yeah, peer to peer. Because usually when you control it centrally, yeah, then they will attack the center, and then the entire yeah, database is compromised. Yeah, so yeah, and then there is yeah, the use of encryption to secure the blocks. So you put them in blocks, yeah, and then you use encryption to still further fortify these data you stored in blocks, and that ensures yeah, the authenticity of any transaction, and it protects against yeah, identities of participants within your transactions. Yeah. So let's look at yeah, where blockchain has been applied. So you realize that in financial transaction, yeah, blockchain really ensures secure and transparent payments. So that is why it forms the foundation for many cryptocurrencies like Bitcoin. Yeah. Then in our supply chain, it can also provide what, yeah, and on what I mean, yeah, yeah, alterable what records, yeah. So it will be hard to really tamper with what I mean your transaction records, and this also enhances what I mean, yeah, transparency and then efficiency. So the fact that I mean your transactions cannot be altered, yeah. So I think it can be a good tool for fighting what corruption as well, because if what, yeah, the records are said that, yeah, people are unable to just what alter the records. So once, yeah, a transaction has taken place and it's recorded, it is done. Yeah, you wouldn't just be able to alter it. Any what new what, yeah, changes or tempering, yeah, will be what hash and then what stored differently. Yeah, so it will be seen as what I mean, yeah, a different transaction altogether. So yeah, once it is what's recorded and then what's yeah, encrypted and added to the chain, then it is what's yeah, done. It's just unable to what, yeah, I mean tamper with these what yeah, blockchain what transactions. Okay, so that is what I mean. Essentially, blockchain, yeah. So it just allow you to what, yeah, record what transaction in what I mean a ledger, yeah, and then it keeps and the ledger is shared among what I mean different blocks, yeah. So they are just multiple copies of what each transaction, yeah, stored in different locations or in different blocks, yeah, such that yeah, you are once you tamper with one, it will be detected easily, yeah, because there are what multiple blocks that what, yeah, will still what contain, yeah, the original record. So let's move ahead. So we have what I mean, yeah, yeah, an example of how the blockchain works. So if you look at what yeah, the figure, yeah, it's what I mean, it shows what I mean the blockchain process with I mean a step-by-step flow. Yeah, so you see that step one, the process begins, yeah, when a user submits an order or initiates a transaction. So this could be what I mean anything from what placing an online order to recording a financial payment. Yeah, then step two, yeah, the transaction is then what broadcasted to peer-to-peer network of computers. Yeah, so these nodes I mean work collaboratively to verify transactions, and that ensures what I mean legitimacy. Then we go to step three. Yeah, once the transaction is shared with other participants within the network, yeah, it validates it, yeah, and then yeah, this is what I mean, yeah, a decentralized process, so where no single entity has what control what I mean, yeah, making what the system more secured. Yeah, then step four, after validation, yeah, the block representing this transaction is what added, yeah, the users I mean the user's chain of what transaction is added to the user's chain of transactions. So yeah, at this point I mean it just becomes what immutable. You can't what really, yeah, alter it. I mean, yeah, it becomes what temper proof and so on. Yeah, then step five, you see that additional activities such as what production, yeah, warehousing and logistics may also what I mean add a new block, yeah, to the chain, and this enriches the records with more details, yeah, about the order life cycle. Then finally with steps six, the process ends I mean with, yeah, the order being fulfilled, yeah, so making the successful what, yeah, completion of what I mean this blockchain what I mean cycle. Yeah, now let's also look at what the challenge, yeah, the challenge of what I mean big data. Yeah, so big data I mean simply refers to what that enormous volume of what unstructured or semi-structured data, yeah, that traditional database management systems are unable to what, yeah, handle effectively. Yeah, so yeah, so this data I mean yeah could be generated from what I mean your web behavior, your social media, sensor readings, and so on. So then with big data, I mean, yeah, we have that massive scale. So that is the size of what data, yeah, that is could be in what I mean petabytes or even exabytes. I mean for yeah, yeah. So or even exabytes. Yeah. So it could be even be much more than that. Yeah. Then you realize that despite what I mean, the complexity, big data can what I mean. Yeah, if you mine the data, you can reveal what patterns, relationships, or anomalies. Yeah, so for instance, what analyzing what, yeah, customer interactions can lead to what better marketing, what I mean, strategies. Yeah, and yeah, so from big data, you may also what I mean, yeah, identify what I mean anomalies. Yeah, so if what there are patterns, they may also be what I mean, yeah, outliers or some abnormal what I mean situations. Yeah, so when you what analyze big data, you are really able to what, yeah, uncover all of this, and that can be what I mean useful for business decision making and so on. Yeah, then we have what some unique challenges. Yeah, and that includes the size and the diversity of what big data. Yeah, so it requires new tools. Yeah, and not just our conventional database. Yeah, for effective management. Yeah, then okay. Yeah, so that is what these are some of the challenges of what I mean big data. So let's move on to look at what business intelligence, I mean, infrastructure. So you realize that, I mean, business intelligence is usually what referred to what, yeah, tools or technologies, I mean, and strategies that are designed to gather, yeah, integrate and analyze, yeah, business, what I mean, data, yeah, analyze and present business data, let me put it that way. Yeah, the infrastructure supports what I mean decision making, yeah, by enabling organizations to really I mean extract actionable insight, yeah, from both what separate systems and then big data sources. Yeah, so the key components of what business intelligence, I mean, infrastructure include what I mean, data warehouses, yeah, which is usually a central repository that consolidates what data from multiple sources for reporting and analysis. Yeah, so it usually what I mean help you to optimize your querying of what I mean, yeah, large data sets and then generating what I mean comprehensive what reports from what these large data sets. Yeah, then we also have what data marts. Yeah, so data mart actually are a subset of what data warehouses that just focus on specific business functions or departments. Yeah, so this could just what you could just extract, yeah, the data that is what I mean needed by a marketing department to create what a marketing data mart, or yeah, you could have what I mean sales I mean data mart, so where you actually what, yeah, push all or extract all sales data and then store it there, yeah, for easy what I mean access and so on, so that I mean you can actually, because it's so big, you actually have to do what I mean some segregation. Yeah, I'd say that's it will what, yeah, reduce the search effort that is needed anytime you have to what I mean retrieve your data. Yeah, and then we also have what we call Hadoop, which is what a powerful open source software, yeah, framework that is designed for big data processing and analysis. Yeah, so it is distributed what I mean architecture. Um, yeah, that, and it enables I mean organizations. Yeah, it has a distributed architecture. Yeah, so it allows organizations to. Yeah, so it is what I mean a modern tool that is what essential for modern business, yeah, intelligence. So that is the Hadoop. Yeah, so the key features and capabilities of Hadoop. Yeah, what I mean. include what distributed parallel processing. So Hadoop processes big data, by distributing the tasks across a network of what, inexpensive computers. So this what scalability ensures what cost effective and high performance, even with what petabytes of data. So that is how Hadoop handles it, and you realize that yeah. Part of what the core components include what Hadoop distributed file system. So that is the HDFS. That provides reliable distributed data storage across nodes. Then we have what reduce. That breaks data into smaller what clusters for parallel processing. And this also enhances the speed and efficiency. So it's like you have what let's say 1,000 data items, and you can actually process them what by with two computers concurrently. So you realize that it will reduce what's the time required to deal with them compared to using just what one computer to process it. Then you also have what the HBase, a NoSQL database that provides fast access to massive amount of what structured and semi-structured data. So with real world application, you realize that Hadoop is widely used by companies like Yahoo and then what NextBio. All right. Then it is also essential for what some search engines like Google and Bing. They also use it to index retrieve billions of what web pages within milliseconds. All right. So let's move on. Still on business intelligence, we also have what we call in-memory computing. So in-memory computing, it's also what's revolutionary, because it changes how big data is processed. What it does is what to leverage the main memory of what computers for data storage and computation. So this eliminates delays associated with what retrieving data from what disk storage and so on. Then so the key features here are what rapid data processing. So this what reduces what processing time from what hours or days to mere seconds and so on. Then real-time analysis. So this allows businesses to what make instant data-driven decisions. And then what hardware optimization. So it requires what advanced and then optimized hardwares to fully what leverage its potential. Okay, so we have what a figure here on contemporary business intelligence infrastructure. So the diagram really illustrates the components of what business infrastructure, intelligence infrastructure, and it is what showing its ability to handle large volumes and varied data types from multiple sources. So if we look at what the key components. So looking at the key components, so we can see that the data sources, there are several data sources that include what operational data, historic IoT data, web and social media data, audio and video data. So that is a variety we are talking about, both what external and internal data. Then there is also what Hadoop data lake. So that handles raw and unstructured data from what diverse sources as well. So those are the green balls together there. So that is the Hadoop data lake. And then it stores what data in its original format for future processing. Then we have what data warehouses in the figure. And that serves as what a central what hub. Transforming and then what loading what data, and then consolidating data for analysis and reports. And then we have a data mart also there in the small cylinder. So that is a specialized subset of what the data warehouse, and then it is tailored for what casual users. So you can see that the casual users, are accessing the data marts. They generate queries, reports, from this data mart easily. Then we also have the analytic platform, that is equipped with advanced tools for online analytical processing, and data mining. So then there is so that is designed for power users, that require in-depth insight and complex analysis. Okay, so that is just essentially what the business intelligence infrastructure looks like today. So let's also do an overview of what the online analytic processing. So yeah, with the online analytic processing, key business intelligence tools, so it is a key business intelligence tool, for multi-dimensional data analysis. And then the key features include multi-dimensional view of the data. So you realize that OLAP will allow data to be viewed across multiple dimensions, such as product, pricing, cost, region, and so on. So later on, we'll be looking at the data cube. That what further explain this. So let's look at the multidimensional data model. So you realize that the so this is a multidimensional model. That allows us to visualize data in the form of a cube. So the key features is that we can do some dimensional analysis. So you can see so many dimensions of the products here. So items include bolts, washers, and then screws. So that is just the product dimension. Then we also have the sales dimension that shows the actual and then the projected sales. Then we also have the region dimension that shows the regions where you are selling these products. So from a relational perspective, you can see that the model actually displays product versus religion. Then rotating at a 90-degree angle. It will reveal product versus actual productive projected sales. Then if you rotate it again by 90 degrees, it's going to highlight region versus actual projected sales. And so this multiple views can really deepen our analysis of the data. So you actually look at data from more than 2 dimensions. All right, so let's try to look at some business use case for this model. So you realize that in the eastern region, we can actually find out the actual and then the projected sales for nuts, bolts, and washers and screws. And then so there are a lot of advantages to modeling this data in the form of a queue. So it brings a lot of clarity in how we visualize data. And then there is also speed. So it will improve the speed and then the interactivity. Yeah, so users can slice, dice, and then rotate to analyze from different perspectives and so on. Yeah, so okay, so let's move on. Yeah, we still have some few slides to wrap up. Yeah, then we'll look at data mining. Okay, yeah, so data mining actually goes beyond analytic processing online. Yeah, so it uncovers what we call hidden patterns, relationships, and then yeah, rules in large data sets. That help us to predict future behavior and trends. So usually the key features here are um, yeah, identifying hidden patterns, relationships in our data sets. Yeah, then so this provide the capability to predict. Yeah, so when we mine data, then, yeah, we are able to make predictions. Yeah. Okay, so with data mining, yeah, we also have types of information that are obtainable from data mining. So we'll look at each one of them and try to understand it. Yeah, so yeah, we can obtain associations among our data, yeah, items or our entities or and so on within the data. So the associations, essentially, yeah, are the relationship between events or items, yeah, that frequently occur together. So yeah, if there are some data items that frequently occur together, yeah, so through mining we can uncover these associations. Yeah, so for instance, customers who buy bread often buy butter. Yeah, so if there is that association, yeah, when you mine your data, you will be able to uncover this association. Yeah, or people whose yeah, wives give birth, yeah, often buy certain things like buckets, new buckets, and so yeah, so there are a lot of associations that you can uncover. Yeah, say that when there are people, yeah, when you uncover this, yeah, so usually those that yeah, give birth, you want to present them products that are usually associated with, yeah, people in that kind of situation. Okay, so let's look at the sequences. So we can also yeah, obtain sequences from our data by mining it. And yeah, so it links events to yeah, it links events occurring over time. That is just a sequence. So you try to uncover, yeah, the events, yeah, how events are occurring over time, and whether there is some causation, yeah, a relationship between the events that really yeah, occur together over time. Yeah, so example would be customers buying a printer, yeah, may purchase ink or cartridges. Yeah, so they could be that yeah, causation, a relationship between yeah, the buying a printer and then buying the ink cartridge. Then we also have classification. Yeah, so classification categorizes data into predefined groups, yeah, based on shared features. So that is what classification does. So it looks at yeah, some key features, and it tries to classify or group yeah, your data items based on yeah, these features. Yep. So example, we could yeah, identify whether a customer is likely to default on a loan based on their profile. Yeah, so that is why at times, yeah, machine learning algorithms can be biased because yeah, most of them, yeah, the intelligence really comes from what classification. So what they do is that they classify, they have a template, yeah, and they what extract features and then compare it to what they have in the template. So already they have a predefined template they've built, yeah, and the template is saying that when you see these features coming together, yeah, then this is yeah, the name for it. This is how to classify it. This is how to understand it. Yeah, so you could yeah, take a list of loan defaulters and you try to identify what is common among these people who usually default on loan. Maybe they are all of they are all within some age brackets. Yeah, or maybe they are all of a particular gender. Or maybe yeah, they are yeah, into some particular profession, yeah, or belong to some particular tribe, belong to, so they have a lot of commonalities, certain things that yeah, features that may be common among yeah, yeah, people or your data items or your entities that you can really use to classify them. Yeah, say that, yeah, based on that template you have built, yeah, anytime you see any person matching these features, yeah, then you make the prediction or classification, yeah, or you classify them, yeah, in that group. Yeah, so that is what happens there, and then yeah, our computers essentially can gain intelligence, through classification. Then let's also look at clustering. So unlike classification, yeah, with clustering, there is no predetermined yeah, template. So usually in machine learning, we call them supervised learning and then unsupervised learning. So you realize that with classification, it is done based on supervised learning. Yeah, you predetermine yeah, some categories or classes, and then you define features. Say that when somebody matches these features, you classify them in that particular class, or you give them that particular tag. Yeah, so this person is likely to default. Yeah, this person is a potential criminal. This person is a potential customer. Yeah, or this person will be a beneficial customer, and so on. Yeah, so that is the classification. But when it comes to clustering, that is unsupervised learning. Yeah, there is no predefined categories or classes. You allow the system itself to yeah, look through, examine, yeah, analyze the features and group them based on yeah, naturally existing yeah, similarities, yeah, between the features, yeah, in your data items. So that is how clustering is done. Yeah, so clustering is unsupervised. Yeah, it's not predetermined. Yeah, and it groups them based on yeah, similarities or things they share in common. Yeah, so for example, yeah, with clustering, yeah, so we could identify customer segments for targeted marketing based on yeah, their shopping habits. Yeah, so you could just um initiate a clustering yeah, process, and it will just look at yeah, key features to extract them and then organize them, and then you have yeah, groups within your database. Okay, then the final one you look at has to do with forecasting. Yeah, so here we use existing data trends to predict future values or events. Yeah, so an example would be yeah, future sales, yeah, uh, based on the revenue pattern. So you could yeah, project that or forecast that. You make yeah, this particular sales, yeah, because of the historical yeah, records or antecedents you have. If this is what you always do, you've done it consistently, yeah, for some years, Yeah, then I mean you may just project that. I mean, yeah, the preceding years you are going to do, yeah, within, yeah, some range and so on. All right, so we also have what I mean text mining and web mining. Yeah, so yeah, here you just extract valuable information from large what I mean text data sets, yeah, such as emails, customer feedback, product reviews, and social media posts. Yeah, and then you use what tools for sentiment analysis, yeah, to determine what I mean customer sentiments and detect trends, yeah, and address what I mean issues proactively. Yeah, so that is with the text mining. Then we have what yeah, web mining as well. So here yeah, you try to discover and analyze I mean useful patterns and relationship in the web-based I mean data. Yeah, so types of web mining can include what web content mining. Yeah, where the focus is on extracting data directly from what content of web pages, and yeah, that could include what text, images, and then videos. Yeah, so an example would be what analyzing product description or customer reviews on what some e-commerce yeah, sites like Jumia and so on. Yeah, then we also have what we call web structure mining. Yeah, so here you are analyzing the structure of web links to understand the relationship between different websites. Yeah, so an example would be what determining how many sites, yeah, link a company's website to access is what yeah, credibility or popularity. Yeah, and then we have what web usage mining. So this examines user behavior through click streams, browsing patterns, and then what search queries. So example here will be what using Google Trends to track the popularity of what set search terms. Okay. All right. So let's also look at what database and the web. Uh, so So you realize that many companies use what the web to make what some internal what yeah databases available to customers or partners. So yeah, typically what yeah, this include what web servers, application servers, database servers. So there are some advantages here of using what yeah web for database access. So easy, it is easy to use what yeah browser software, and then the web interface requires few or no changes to your database, and it's just not expensive to add what a web interface to the system. Yeah, so we have what a figure here. Yeah, so um yeah, so the figure demonstrates how users access an organizational internal what database through the web interface using what a desktop browser. Yeah, so mobile applications and other devices. Yeah, so we can see the flow of what information from user requests to the database, and then back. Yeah, so there is that back and forth, and then there is the emphasis on what yeah, seamless interaction between what the various components in the structure. So so we realize that the client with their web browser, yeah, so here the user can what yeah, initiate the process by sending a request via the web browser or a mobile app. Yeah, and the requests are typically what the form of HTTP, yeah, or HTTPS. Protocols. Then yeah, so the internet here, which is what that's yeah web of what yeah sort of yeah web like item there. So that serves as a medium to connect the clients, yeah, to the organization infrastructure. So this will also ensure yeah, reliable communications. Yeah. Then we have the web server. Yeah, so that processes incoming requests and then routes them to the appropriate application servers. Yeah, then the web server also delivers pages and other content back to the clients. Then we have the application server that acts as intermediary between the web server and the database server. Yeah, and it executes the business logic, and it processes your queries, interact with your database server. Then we have the database server itself that retrieve or update data based on application servers queries. Yeah, and it hosts the databases with stores of all organization structured and unstructured data. Then we have database, yeah, the repository, yeah, where you actually store your organization data. So that is it. Okay, so somewhat, yeah, points to discuss here. Yeah, so why are a multi, yeah, server, used in the setup? Yeah. So why is it really necessary to use multiple servers? So you can see that we have the web server, application server, and database server. Yeah, so usually when you separate the responsibilities, yeah, web hosting, business logic, and then database management, this will enhance performance, security, and then scalability. So these are some of the reasons why. Yeah, and then the role of the internet in ensuring secure data access. So you could see that yeah, they employ HTTPS. When you see the HTTPS, that is yeah, secured. So that means that there is yeah, some encryption and firewalls. Yeah, and the internet safeguard data as it travels in the client and the server. Yeah, and then the final question you should also yeah, think about yeah, has to do with how organizations yeah, can optimize this infrastructure for mobile users. So in my opinion, they can do this by employing responsive web design APIs and then mobile friendly interfaces, yeah, to really ensure smooth access to all their devices. Yeah. Yeah, so to summarize, yeah, the architecture we are seeing really highlights yeah, the interaction between the users, yeah, and then the internal database through web technologies. Yeah, so they leverage this setup yeah, so by leveraging this setup, you realize that organizations can, yeah, provide security, efficiency, yeah, and then friendly user access. Okay, so now let's look at data governance. Yeah, so yeah, so data governance. In organizations, yeah, yeah, it's really important. Yeah, and then it refers to the processes and then the policies that you require to manage data, yeah, which I think is vital. So yeah, you should put in some policies that ensure accuracy, reliability, and accessibility for your stakeholders. Yeah, and to also really support decision making and operational efficiency. Yeah, so. Yeah, so in short, data governance, really refers to policies and procedures that define how data should be managed within an organization. Yeah, and they should be treated as strategic assets. Yeah, and then you can use it to align your organizational goals with the compliance, requirements within your jurisdiction. Yeah, so for data governance, you have to really establish some what rules, yeah, and what best practices. Yeah, so you must just have what guidelines, or this should just include the guidelines, yeah, for sharing, yeah, data within and then outside your organization. So if you don't have that, you are lacking in your data governance standards. Yeah, so how data is shared within and then outside. Yeah, you should have rules and then policies on that. Yeah, dissemination of information responsibly. Yeah, when you are giving out information, yeah, that should be done responsibly, and there should be what rules for that. Yeah, then we can talk about acquiring data. Yeah, so you have to be ethical when it comes to acquiring data. Yeah, then standardizing the formats of your data is also something you have to work on. Yeah, and it should be part of your data governance. Yeah, so sometimes having internet challenges, so that's why at times you realize, I have to break and then connect, my internet. Yeah. Okay, so that's just by the way. And then I was just talking about some of the guidelines for creating data governance, policy within your organization. So sharing, rules, determination of rules, yeah, etiquettes for acquiring data, standardizing the formats and then technologies that you use in your organization. You don't just allow people to use any technology, to do your organizational work or your business, activities. Then classifying data for security, and then organizational purposes, and then yeah, creating inventory, of data to maintain visibility of available resources and so on. Yeah. Okay. So let's move on. Okay. Then we also have data quality assurance. Okay. So you realize that quality assurance is important in trying to maintain reliability and actionable information within your organization. So if you have poor data, then even though data may be the new fuel that is powering the economy, but when you have poor data, that will be counterproductive. It means you'll be making bad decisions or the wrong decisions, in terms of your investments and so on. Yeah. So let's look at some of the key points here. That is what data accuracy in business. So over 25%, of critical data, in the Fortune 1,000 companies is established, to be inaccurate, according to some studies. So so steps, before you implement new database. So you must identify and correct faulty data. Then to do that, you have to review the current data for inaccuracies, inconsistencies, and then duplications. Then you also implement corrections to ensure that the foundation of the new database is clean and reliable. Then you have to establish routine for data editing, develop and enforce procedures to maintain data integrity. As the database evolve, because databases are an evolving thing. It's going to expand, because data is important, so you never discard or throw it away. So as you expand your business, add more business portfolios, and then products and so on, your database is also going to evolve and then grow bigger and so on. Then data quality audit. So you have to regularly audit your database to understand who accesses it, the completeness of the database, the consistency of the data. So this will allow you to detect discrepancies early. If you are doing some regular quality audits on your database. Then we have data cleaning. So systematically you should correct formatting issues, remove outdated or redundant entries. Then eliminate duplicates. And this should be ongoing. It should be something you do from time to time. So this is really supports your analytics and reporting based on the data. Okay, so let me see. So that is all we've talked about data cleaning, and so finally, how will MIS help your career? So essentially with regard to what we have learned from database, you realize that if you actually follow through and then try to expand your knowledge on your database management. So at least right now you understand what data governance is, and then the various the issues with the traditional file system and now the database management system. And we also even looked at the issues with the database management systems, where we actually said that big data is now an issue because our conventional databases can no longer handle it. Then we need the NoSQL database. And then so with some of these important information, you have to build on it. We looked at the database itself, how data is stored. Then we look at how to query the database. You've actually seen a sample code from SQL. Then we looked at even Microsoft Access, how to generate queries and so on. So if you actually really expand on some of these things, you should be able to also look at data analysts, opportunities and so on within your organization. And with position of data analysts, you may be required to have proficiency in maybe SQL, Excel, and other data visualization software like Tableau, Power BI. Then you need some analytic skills, so the ability to interpret complex data and communicate actionable insights. It's also very important here. Then collaboration, that is working with other people. So that will also be key for a data analyst position. And so essentially that is it. So if you can expand on some of these things we've talked about already, then you can be looking up towards some new opportunities, like data analysts within your organization and so on. And at times even whatever you are doing, you realize that if you need to analyze the data, so some basic analysis or moderate analysis, you should be able to do that and then deliver it and so I'll draw down the curtains here, and then all the best.